that it's not always possible, complete, or cheap. And so these are two examples. One is with the strategy of early planting, the adaptation works. This is with climate change scenarios. The other one is change of cultivar. It is unable to reverse the damage due to low precipitation. So there are definite limits to adaptation, and I think we need to be clear about that. A final point on this, the mitigation and adaptation, is that they can be interactive. And there's been a tremendous bifurcation. All the mitigation folks are on one side, the adaptation people are on the other. But there are many things that actually can do both. And I think that, while I don't want to push this too far, but I think that we need to think about this, that they can be interactive so that, for example, carbon sequestration can help farmers adapt to climate extremes, because there will be, both in times of drought and in flood, it's going to be helping on the water resource side for the crops. So that's what this model result is testing with nitrogen fertilization, irrigation, current climate change, and with two different scenarios. Another part why we have to do this is, and we have to test, by the way, the carbon sequestration projections of, there's been a lot of work on how much carbon agricultural soils can actually sequester. But most of those estimates do not take the climate change scenarios into account for the 50 years that that carbon sequestration is going to be happening. So we also have to be meshing the changing climate as we into those projections. Coming to the end now of the strategies. One thing that's very much happening now in terms of strategies for solutions is to use current climate extremes as a pathway to climate change. So especially in developing countries, when there's real issues today that everyone is working on, thinking about what's happening in the 2080s may not be the absolute best approach. And so working with seasonal to interannual projections, working with what's happening with El Nino and the other climate variability systems, then help make a transition to and a way into the decadal to century timescales of climate change. So basically, to sum up, certainly on the adaptation side, what the real new paradigm has emerged, in which the operative word is risk management. And I think so much ag work has been done thinking about climate on the left-hand side, that here was the current climate, there was a normal, and we had some kind of variability, extremes up and down, but they were very random, and so you just took the droughts and the floods as they came. Where we are now is on the right-hand side of the graph, that we are in a changing climate. And so when we're doing anything thinking about climate in relation to any of our agricultural processes and production systems, we need to just automatically look to see what's happening with trends, because that's what's happening to that system. And then from that, you can begin to see that there's a coping range that we have for a certain, we can withstand whatever system we have, a certain amount of climate extremes, but beyond that, we have to think about adaptation, but if it goes way even higher, we are in a vulnerable situation. And so one of the things I think that we can do as agronomists is help characterize the thresholds for the different social groups, agroecosystems, regions, and nations. And then this is my final strategy for solution, which is to monitor climate, adaptation, and mitigation and reassess. And so with this, we did with an OECD workshop with folks coming in from different countries, different ag systems, ag production systems, thinking about what should we be tracking in an organized way to really figure out what's going on here. So these metrics are let's get organized to have what's happening with our biophysical indicators, climate, soil, crop calendar, what's happening socioeconomically in terms of our trade flow, our agricultural sector in subsistence, in poverty and equality, looking at what's happening with the adaptive capacity of our ag system, and then also look at our climate mitigation programs as well, because that is part of our risk reduction management system. So final thoughts. Solving climate change requires strong and continuing interactions between researchers and decision makers, since the climate, the science, and the solutions continue to evolve. This is not that we're going to say, climate change, check, we've got it. Thank you, scientists, goodbye. The society cannot do that because we will really be in trouble. We all have to work and interact and work together to solve the climate change challenge, some would say crisis. I really believe that agriculture in general and Iowa specifically have an important leadership role in responding to climate change. This is not necessarily so obvious to everyone. I've been on panels with representatives from NGOs, and they say, "Oh no, it's just the fossil fuel utilities. It's just the coal burners. Only they should work on solving this." And I disagree with them. I believe every system, every sector in the economy has to, and every country, developing and developed, have to work on both reducing greenhouse gas emissions and preparing to adapt. And agriculture is an important bellwether sector. We are still, in every country in the world, we are a foundation sector, and we need to provide leadership on climate change. And Iowa, of course, is the as I said in the beginning, is the heartland of agriculture, in the heart of agriculture in the United States, and Iowa is already playing a leadership role and needs to continue. So that's why I want you to see if you can create my challenge of a sustainable ethanol. Think about it. It's like it's like one of those new irrigation circles. Think about those 50 miles radiuses around the ethanol plants that are going to be green. And my final thought is, despite posing tremendous challenges, climate change is the transformative issue by which sustainability may be achieved. Thank you very much.
Thank you, Cynthia, for that wonderful lecture linking together climate change, agriculture, and also showing us a way to go towards the future. My name is Bill Gutowski. I'm a professor of meteorology here at Iowa State, and I'm going to be moderating the next phase of this evening, which has two steps. First, we have a couple of people that we've asked to give brief responses to Cynthia's lecture, giving their perspectives on what Cynthia said tonight. And then we want to open up the floor to all of you to ask questions of Cynthia primarily, but also of our respondents if you want to. During the
doesn't have to be a question. Let's really make it a colloquium. I would really just share what we think about climate change. It is such a challenge.
if you didn't hear,
If
you didn't hear Cynthia, she said let's not just make this question and answer. If you have comments, to points to bring up, let's make this a colloquium. When you do want to make your comments or ask questions, I ask that you line up at the microphone here in the middle of the room. And please try to limit yourself to one question or comment so everybody gets a chance. And also, out of deference to Cynthia, because she's had a real whirlwind of a day here, we'll probably keep the question and answer or comment session to about 30 minutes or so. But I'm sure she would love to hear from you afterwards as well. So first of all, our two respondents. We'll have two people. One is Gene Tockley, who's also a professor of meteorology and also agricultural meteorology here at Iowa State. And he'll be followed immediately by Sarah Carlson, who's a graduate student in the program in Sustainable Agriculture and Crop Production and Physiology in the Department of Agronomy. So, Gene.
Thanks, Bill, and thanks, Cynthia, for a terrific presentation. We all enjoyed it very much, you can be sure. There are two graphs that you showed that I want to just focus our attention on. One was where you plotted on the horizontal axis some kind of climate change. Oh, I can go back? Let's see. Oops. I'm going to come back to this one too, but if we just go to this one, you'll notice that there's a region, as you pointed out, a region of improvement, and then followed by long-term consequences which seem to be negative. And so I want to focus a bit on this region of improvement. That's the one which we face in the near term, and it's the one which we have better data on. We know what the trends are now, and we perhaps have more confidence in what the models project for that near term. And so what do we do about that? And how do we best position ourselves to adapt to that particular time period? And the other is then this very good slide on the what is normal or what is not normal anymore. This one right here, and this is really nice, where we have this planning, the coping range, the adaptation range, and the vulnerability. And so what I'm going to do is, first of all, I'm going to just say a few things about. You notice there's no scale here. There's no variable, and so this is kind of a stylistic. But let's put some variables on there. What is changing in Iowa? I mean, that might be kind of interesting for us, since we live here and raise our crops here. We know that we have now a longer growing season, so we can plot growing season, and we know that's going up. It's observed, and the models project in the future that it will continue, so we have high confidence that the growing season is going to be longer. We know that despite your one graph that showed increases in temperature in the Midwest, that was the annual average, and we don't grow crops in the wintertime here, but the summertime temperatures are going down. It's actually gotten cooler here in the Midwest in the last 25 years. Generally, that's been pretty favorable for crops. So again, it's been a trend. It's been the opposite direction, but it's been in a good direction for raising most of our crops. We've had an increase in nighttime temperatures, and that is also projected by the models to increase, to continue. So we know that, again, there's a factor that is at play, and that may reduce our risk of late spring frosts and early fall freezes. So again, extending the growing season or making us less vulnerable to negative climate impacts. We have more precipitation. That's been measured, and you indicated, and I agree fully, the models are inconclusive on what the future projections are, but there are some models that project an increase, and to the north of us, generally an increase, maybe a decrease to the south. We don't know where that line is, but it could be. But the past records show an increase, and so that's also favorable for agriculture generally. Now, you point out that the risk of waterlogging is a potential problem, but in the state of Iowa, we have a lot of poorly drained soils, but we also have over 1 million miles of agricultural drainage tile. We have enough drainage tile to go to the laid end to end would go to the moon and back twice. They're on 30-foot spacings, and that's about the width of this room. And there are poorly drained soils, so that can move a lot of water away. So we're somewhat we've buffered ourselves to some of the negative impact of increased precipitation. More precipitation means more soil moisture, and generally that's better for agricultural crops. So the list gets long. We could have more freeze-thaw cycles, and that would be a mixed bag, but one possible positive of that is that if we have more freeze-thaw cycles, it may open up the soil for recharge over some periods during the winter, which generally we don't consider soil moisture recharge to be taking place during the winter, but it could if we have more freeze-thaw cycles that open up the soil to charging. So that would make it more likely that we would go into the planting season with a good full profile of soil moisture. There's some indication of increased cloudiness, and increased cloudiness, if it isn't and some of the plant physiologists will check me on this, but if you have partly cloudy skies, you get actually more radiation than if you have clear skies. Isn't that right, Ray? If you have partly cloudy skies, there's more solar radiation coming in, and also it's coming at different angles, so you might get more photosynthetically active radiation on a partly cloudy day. So cloudiness may in fact increase photosynthesis, and that also increases nighttime temperatures. Higher dew points, that's a current trend. Higher absolute humidities, which that in turn raises nighttime temperatures. It also reduces moisture stress. It could also increase vulnerability to certain pests, funguses, and so on. And of course, then higher CO2 is a fertilization effect, which in itself leads to faster crop growth, but also increased water use efficiency, as you pointed out. So, for a number of reasons, here in Iowa, we have at least a short period of a few, maybe a decade or two, of perhaps even better climate. And so how do we use that to promote alternative practices and sustainability? And another aspect of this that was really came to my attention at the noon luncheon, we had two representatives from Africa. We had Francis from Ghana. Is Francis here? And Hadan from Uganda. And Francis mentioned that climate change has impacted his family. They used to be able to raise cocoa, but climate has changed not necessarily because of greenhouse gases, but it has changed so rapidly that they no longer are able to raise cocoa. In Uganda, the main crop is coffee, and only 2-degree rise in temperature. It's pretty high. It says the elevation is about 3,000 feet. And it's very favorable for raising coffee trees, but an increase in temperature of only 2 degrees would reduce the coffee growing region of Uganda by over 90%. Just a 2-degree temperature rise. So a very sensitive region to climate change. By contrast, we here in the central U.S. and Iowa have a very robust climate that is far less vulnerable to climate change in the short term, or to reduced agricultural production in the short term. So how do we best use this window of opportunity? And maybe it's the sustainability and the ethanol green footprint. I don't know, but let's think about that. That's the message that I have. Thank you.
Hi, can you hear me? Okay. So the title of my response tonight is From Lessons Learned, which Dr. Rosenzweig talked about, to the actions that we've taken here in Iowa. And I'm specifically focusing on Iowa because we're here and I'm sort of ignoring the developing world right now, which we talked about today at lunch. So opportunity is defined as a favorable juncture of circumstances or an appropriate or favorable time to achieve a goal. Winston Churchill's view of opportunity was that the pessimist sees difficulty in every opportunity, while the optimist sees the opportunity in every difficulty. Just thinking about Dr. Rosenzweig's presentation and the thought of global climate change is somewhat overpowering and challenging to the average citizen, us. But if we can be optimistic, this will allow an opening or an opportunity for the common man and woman to do extraordinary things and be part of the solution phase, which Cynthia talked about. So whenever a task seems too daunting, it's good to first take stock of the resources, networks, and infrastructure that already exist. Tonight I'd like to take a few minutes to highlight just some of the assets we have available in Iowa due to the work that Iowans have initiated, which not only face the challenges of global climate change, but that also, 1, increase our strength as communities, 2, increase our courage to seek out knowledge that may be contrary to set beliefs, and 3, to focus our human behavior to more positive ends. First, Iowans have created and continue to support alternative food systems. Iowa has over 172 farmers markets, making it 3rd in the U.S. and 1st per capita. Iowans are also members of community-supported agriculture farms, which number 50 in the state and range in membership of 30 to 150 each. These consumers receive produce grown by local farmers and also directly support these enterprises. Also, grocery stores and co-ops like Fairway and Wheatsfield here in Ames actively procure locally grown items, and this year the ISU Dining Services has included in its annual budget spending for local, organic, or sustainably grown produce. Just today, the Dining Services Director met with local farmers to ensure that the majority of this produce is purchased locally. Now, Iowans may support a local food system because they want to decrease the environmental effects which food transported long distances can create, or because they enjoy a connection with a farmer or community. Either way, each opportunity taken has created an alternative system, this alternative sustainable system, which helps to mitigate global climate change by decreasing carbon dioxide emissions while increasing our adaptive capacity to these circumstances through stronger communities. So second, Iowans have initiated alternative research projects here in the agronomy department, as talked about with Dr. Pesick's research that was done, and also which paved the way for current research that's done by, for example, Dr. Matt Liebman's long-term rotation study that's showing that a 78% decrease in herbicides and a 73% decrease in nitrogen fertilizer is necessary in a longer rotation, but you can still achieve the same corn and soybean yields as compared to a 2-year rotation. In addition, Dr. Mary Wiedenhoff's 3-year and 4-year studies in Northwest Iowa have given similar results. Other professors like Dr. Lance Gibson and his work with small grains, Dr. Charlie Brummer's work with forages and perennial polycultures, and the work of the National Soil Tilth Lab are all examples of opportunities taken by people at this land-grant institution to prepare farmers with knowledge that increases their adaptive capacity and flexibility to the unknowns that global climate change will bring. So third, Iowan organizations such as Practical Farmers of Iowa, which has conducted more than 600 on-farm experiments since its inception, and the Leopold Center for Sustainable Agriculture, which has conducted numerous studies in its 3 focus areas of marketing, policy, and ecology, are both organizations providing Iowan farmers and consumers with knowledge to make informed decisions and increase their participation in advocating the farming and food system we want to see. Now, even if your only involvement in agriculture is by eating, you can still get involved and have an impact. Groups all over the U.S. are actively participating in organized movements like the National Step It Up campaign. Our own Step It Up campaign here in Ames, Iowa, which is organized by a graduate student in the Sustainable Ag Program and plant breeding programs, has formed a group of volunteers that on April 14th of 2007, so just in a couple months, that will join out 749 other community groups all over the U.S., and they're going to push our federal government to cut carbon dioxide emissions by 80% by 2050. Hopefully you'll be inspired to participate in the fun on April 14th and even sign up as a volunteer, and you can see me later because I don't think Julia's here tonight, who's the organizer. So in conclusion, these actions which Iowans have initiated to mitigate and adapt to the challenges of global climate change are also rebuilding communities and increasing popular participation. This civic capacity is fundamental to be able to withstand the unknowns that this new climate system will bring us. I hope that I leave you tonight feeling optimistic about the ability for your involvement in this process, but also with a sense of urgency for you to take advantage of the opportunities which have not been taken. Because the opportunities exist, now all it takes is us to make a difference. Thanks.
Thank you for those responding comments. I think both amplified in very important ways some of the more general comments that I made. So it's really bringing home to Iowa, both some on the climate side and on the solution side. So I really appreciate the remarks.
Could you comment a little more directly about
Effects of ozone on crops? Or...
Effects of ozone on crop productivity rather than just CO2.
Yeah, well, I mentioned it. This is not my field, and so I don't know specifically. I just know that tropospheric ozone, increases in tropospheric ozone can be damaging to crops as well as the CO2. So, for example, some agronomists or atmospheric chemists like Bill Shimides, when he was in Georgia, did studies of the air pollution effects, for example, downwind of Beijing, and found crop damage, significant crop damage on the crops. So really what we should be doing is what we call multiple stress studies when we do our projections, so that we do the effects of the other pollutants on the crops as well as the changes in climate. Just certainly on the sulfate aerosol side, another pollutant, and perhaps to a certain extent ozone as well. There, in terms of long-term projections, there is the hope that other countries, that we've done a lot in our country to reduce those with the Clean Air Act, and that those benefits will continue, so that those effects will decline over time. But then that leaves, ironically enough, that then it leaves the warming to actually be even more damaging, because the sulfate aerosols is a cooling effect on the climate, even though damaging on the crops. So what we need to do is multiple stress studies, including those.
I appreciate the presentation, and congratulations on all the research you have accomplished. I'm interested in knowing more about how much change is actually already in the system. Like if we were able to, because everything you presented in this, like from this point forward, and like when Mr. McKibben was here last week, he said, they said, we had 10 years a year ago, now we're down to 9 years to act.
Right.
Do it now.
Yeah.
How much is actually, if we were to be able to split the switch right now, how many years would it be before we actually saw things stabilize? How much change inherent in the
Yep,
system?
I'm getting it. This graph, I forgot to, as I was focusing on the projections, and yeah, can I do it from here? Great. This curve right here is the year 2000 constant concentrations. It's the exact answer to your question. If we were to stop right now, we would have, what it is it's about the same amount of warming that we have had already, which is we've had 0.7 degrees C over the past 100 years. This to here is 0.7, and if you go here, it does go up, and it's about the same amount of warming. This is the committed warming. It's known as the commitment simulation. The issue is that what you need to understand is that this is not realistic. It's not what we don't call this a scenario, because it is completely unrealistic, because we are not going to stop our greenhouse gas emissions and freeze them tonight. And so it's important to understand, and it's a very important question. I'm very glad you raised it, because I realized when I went by it, I said, I didn't talk about the commitment run. Because of the radiative forcing that we have put into the atmosphere already, because of the long lifetime of the CO2 molecules, there is this, and the thermal inertia of the ocean, there is heat ready to, has not been manifested yet. And this is the projection. And it's on the order of 1 more degree C. It's just, but you have to realize this is not realistic. Now, it's great that Bill McKibben came. He's so terrific, and he's doing a great job, again, energizing the general public to be active on the issue. My personal view is setting limits is helpful for to galvanize people, the actual science behind those, and saying now it's gone from 10 years to 9 years. As I hope I demonstrated, the climate system is a lot more complex than that. It's very, very hard to make that specific a time frame. The issue is truly important. We need to address it. We need to address it right away. But I also believe, again, personally, that it's a learning process. We need to begin right away and then see as we progress. Dennis?
There's some projections or movie projections out there that we get some tipping points.
Uh-huh.
Instead of your nice little graph of lots of adaptations and
Yep.
planning stages we get reversed climate change. And how is science addressing this? Is this a realistic scenario that could happen?
Yeah.
1 in 100, 1 in a million
Yeah.
type of thing? Because if that happens, we're all in a different world entirely.
Yes. Right. This is also, all of these questions are all very, very, very important. Tipping point is one of the new jargon phrases of climate change. And so we have tipping points on the climate side, we have tipping points on the impact side, we have tipping points, I think, on the solution side. I think that it actually is, I think it's also very germane to the solution side that we're trying out the different solutions, and at a certain point there will be a tipping point in which adoption of the real new energy system that we're just trying different possibilities on right now. So I think there will be tipping points. In terms of the climate system, there is the potential. So a tipping point is the potential for a non-linear shock in the climate system. That's where it really came from. And it is, I have to say, it is again a topic of intense scientific debate. There are some very respected climate scientists who believe that there can be tipping points. For example, that the melting of the Greenland ice sheet will progress little by little, and then there will be we will pass a threshold that the graph that we were looking about thresholds really is germane to this as well, and that then Greenland will melt precipitously. Other scientists who model Greenland ice sheet, who model ice sheets and Greenland in particular, they put in the data the processes and the data that have been observed so far, and they do not see the potential for a tipping point. So I have to say, I think that we don't understand everything. I think we all would agree there's the potential for nonlinear surprises and shocks. But there is also scientific debate on the particular ones. Thermohaline also, which is the other one, a reversal of the thermohaline circulation in the ocean, that conveyor belt that carries the warmth around the planet. That's the other big one that people talk about in terms of a tipping point. Again, I've been cautioned by climate science, my colleagues because I'm bridging two decision makers a great deal, and they caution. I've been cautioned. Be careful. Don't say that the thermohaline circulation is going to reverse like that. It's really, it's very, 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 very unlikely. And let me just say about the melting of the ice sheet too. If it continues, the time frames are also very important, I think. So you see, very often people don't say what these time frames are. The way it sounds now, it's like the Greenland ice sheet is going to go and we're going to have 7 meters of sea level rise, like in 10 years or something like that. It's not at all like that. I did the back of the envelope calculation for the Greenland ice sheet, for the rate of melting determined by remote sensing, wearing my NASA hat. It would take over 2,000 years for Greenland to melt at the rate that it is melting, at the accelerated rate that it is melting now. So I think we need to keep on looking at all these things, monitor and reassess. And but very low probability, but potential. Yeah.
You mentioned a little bit about carbon sequestration.
Yeah.
I read some articles maybe a year or two ago about, I think it was German scientists, and found that methane was released in plant respiration. And I haven't heard much about it, but talking in Dr. Conley's class, methane is 20 times as effective as greenhouse gas as CO2. And so plants are releasing nothing when they're respiring, and putting all this money in carbon offsets to keep our minds really best
Yeah.
I didn't know if you had anything about that.
Well, I don't know anything about that specifically, but there are just as so many people here are really looking at the ethanol production and what it really means and what the process is and what the implications are in all the aspects. It's the same with carbon sequestration. I mentioned some of them in my caveats, but there are others as well. And I know the folks in Nebraska, I think, are doing a long-term study now on carbon sequestration, and one of the scientists doing it came to me and said, we're not finding anything in the first couple of years, so there's, again, some real issues. We're just getting going. And, there's been, one thing I say is, there's been probably billions of dollars put into the climate models so far. One of the things, when I go to Washington, I talk about we need billions of dollars on the impact side to improve the models that we use and to do the experiments that we need to really work on the solutions. I mean, I don't want to deprive my climate scientists of their funding, but at the same time, I think it needs to be more balanced now.
So one funding question. NASA has kind of had a shift now back to more exploration, human exploration, moving Mars, beyond. How do you feel about NASA's commitment to monitoring climate change in the future? Are we going to have sufficient resources to do that, or are you very concerned about how our remote sensing ability may be diminished on Earth?
Right. It was called the transformation. I mentioned climate change as transformation. The transformation at NASA that happened in the last couple of years, in which the focus turned from Earth system science to the solar science, and with a more focus on space. So I sat at actually many meetings, and I would say, there are no climate impacts in space. It's just like, this is not what, you guys can go ahead and do whatever you want there. This is not what I do. What we have done at GISS is we have, I guess I would say, kept the faith. And we have done the research. We've kept the research programs going no matter what, because we're following what we believe is important. Having seen this transformation, I want to be constructive in hoping that there will be further transformations in the programs. I think NASA has played an enormous role in understanding climate science and global climate change, and I think it will continue again despite this hiatus.
Cynthia, in some of the studies of global climate change, especially with respect to agriculture, have indicated there are going to be some areas, as you pointed out, in big winters, and on balance, though, that there isn't going to be too much overall impact on global food production. Most of these have involved economists, and as you pointed out, economists love to adapt. In addition to that, they believe in markets and they love to trade.
That's right.
So one of the arguments that comes out is that this is just going to change trade flows.
Yep.
And that on balance, the world is probably not going to be worse off. How do you respond?
Yeah. I really actually, and I want to continue, John is one of the people that we've worked together for a long time, and I want to continue this conversation with you. Because I think, again, that we need to have, we need to hold two thoughts in our brains at the same time about the issues that you were raising. I think that we are going to need trade because there will be shifts in comparative advantage. And that's what this changing climate does. Some regions don't do as well, other regions do better. And by the way, when we did our original study, because we did do the original study on this, we found that we did the original study that the U.S. got better in terms of ag, but the higher latitudes, in particular Canada, and at that time it was just as Soviet Union was changing, the former Soviet Union did better. And so the comparative advantage was, while we got a little bit of the comparative advantage, the higher latitudes got even more, which was a very interesting result, I think. But I also think, so we clearly trade is very, very important. At the same time, I think we need to nurture our agroecosystems everywhere in the world at the same time. And I think probably we need this paradigm now anyway, given the whole debates that we're having about globalization. I believe agriculture is a common good. It is a public good, and it is, and it needs to be. I believe that it should be supported everywhere. So while trade will help in terms of responding to climate change, but we need those agroecosystems in place for adaptation purposes, because there are genetic resources and in some subsistence systems, indigenous systems, that we're going to need, and that we're going to really need to work on sharing those resources. So John, I'm giving a lot of homework assignments. I want you to figure this out so we can have trade and wonderful protected agroecosystems at the same time. I know it's not easy. So, good.
Thank you, Dr. Rosen. I just had a question in terms of, though much like most people in you and I have seen that the policy has a tendency to become stale and not to advance very slowly. And I think sometimes earlier you had said that when someone like Bill Gibbon puts out that there should be limits, that are so we should try and cap some of these issues. That these are helpful to think about, but we think that the caps may be perhaps arbitrary or they may be premature. I would just like you to respond to the statement that don't the caps serve an interim use in the sense that they provide a direction with which to move forward, and that in that of itself provides a certain utility that by debating about those caps sort of ad nauseum would seem we disservice all of them.
Yeah. Sure. There, in terms of mega policies, there are two main ones that are put out to deal with climate change. One is, as you say, cap and trade, and this is to set a limit on the amount of carbon dioxide emissions, and then to allow the market to distribute the response to the policy, so that the market is efficiently distributing where those emissions will take place. And in order to have a market, you have to have a cap. So if we want to do a market-based system, then you need to have a cap. There has been definitely a disconnect in this country, kind of saying, "Oh yeah, let's have a market," but a market doesn't happen. Again, we need to in particular on this. Europe has a cap and trade system. It has a market system, and there have been problems with it. In terms of setting the wrong price for carbon is one of them. And that, I think, proves my point that we need to do a lot of experimentation and learning to see what programs are going to really work. So cap and trade is one of them. And in the Northeast, we have a regional greenhouse gas initiative, and we are going to set, it was started by New York State, actually. Governor Pataki, the governor who was for the past 8 years was our governor, he started it, and it will be a cap and trade system. And the utilities are getting on board, and it's really very exciting, and it's a kind of laboratory for the rest of the country. The other major policy mechanism is carbon taxes. And I think the Stern Review that just came out of the UK economists, they felt that carbon taxes also could be effective. One of the things about taxes is that it sends a signal to everybody. One of the things that we've talked about is how the issue is so transformative. Basically, I was saying every sector has to work on this. Every person has to work on this. And taxes are very good because they send the signal that we all have to do our share. So I guess I feel that we need to experiment with the policy, see what works. I think having a system and then evaluating, because it is still early days. Remember, I use the phrase test and try and test, and I think both of those should be tested. Yeah, let's see. Whoops.
As you get there, I just want to make sure I understand. There are some scenarios in which agricultural potential goes down with lower levels of climate change. You have on
Yes.
the lower two lines there.
Mm-hmm.
And then, second, you talked about this is agricultural production potential, most of which is declining in, as I understood your presentation, Africa and equatorial areas. The increase in potential is Canada and Russia.
And the U.S. and other.
Lesser extent the U.S.
No, it's still the U.S. is definitely major. I'll show you another. Okay, so we're looking at this.
Okay.
I'm going to show you, and there's a map that we'll look at too.
Okay, well, here's my question. So even on that upward production thing, you're counting on productivity increases out of places like Russia in that. This is a potential slide. So I've got some questions whether we ever actually get that extended increase in the near term. My biggest question, though, is that the 0 to 10 scale there, have you tried to correlate that using the models with 450 parts per million, which at this point I don't think we can even get to, 550, 650, 750? If you looked at that, because this is the urgency debate discussion we've been having.
Yes.
For those of us who think it would be a mistake to write off 450 parts per million, because that might be what we really do need to do. Boy, we're coming at this with a lot of urgency.
Yep.
We got to get this going now.
Yeah.
Got a chance.
Yep.
But if you say, well, we've gone to 3 parts per million, you go 450, you go to 500, don't worry about it. Well, then maybe you do have a couple of
Right.
days to figure things out.
Right.
So can you try to match that downward tick with atmospheric concentrations or
Yes.
equivalent
Okay.
of that?
This is a very excellent question, and it really is the place where the climate science, the impacts, and the mitigation come together. It's closing the loop and saying what damages will be avoided if we stabilize at 450, 550, 650, 750. In essence, it is the ultimate. You've asked, I believe, one of the main ultimate questions on climate change that was posed to the Intergovernmental Panel on Climate Change when it started about 20 years ago. And this time, in Working Group 2, for the first time, there is a table that gives, up at the top, there's 2 parts to it. I have it upstairs in my room, but I can't release it yet. That's why I couldn't show it tonight. But if I when I come back, I'll be happy to talk about it and explain it, because it is providing exactly for the first time, really, from the impacts and adaptation scientists, the information of what damages occur at 1 degree, 2 degrees, 3 degrees, 4 degrees, and higher, and associates those temperature degrees with stabilization scenarios, those changes in temperature. And it is a very important policy tool. So I can't go into it. I can't give you the specifics now. In first week in April, it is in the summary for policymakers, and you will be able to find that answer. It is extremely important. I agree, and I also don't want to. I guess personally, I do feel 450 is. It's an enormous challenge for us to. We're at 370, 380 now. we've been going up every year. The emissions go up every year, so it would have to be massive changes. But I don't want to cut anything off, and having a big push in the beginning, like Bill and Jim, my boss, is very much. He was you might have seen, he was at the National Press Club yesterday, and called for a moratorium on all coal burning plants. That was yesterday. Or the day before. That was just in the last 2 days. So there is a lot of momentum building. We'll see. But hold the thought for that table.
I'm sure you and others are aware that Al Gore, his name slips my memory, but a very wealthy Rick is offering rather large sum of money for a technological fix to the overabundance of CO2 in our atmosphere. My general opinion is probably that happening. I'd like to hear your comments.
Your general opinion is what?
Is that it's a bad happening, right? Industry would be a way to overexploit the atmosphere.
Yeah, it's the owner. The person who's doing it is the owner of Virgin Airlines. That's it. His name is Richard Branson, I think. Yeah. This is what I feel, and also following from the previous comment as well. We probably shouldn't be too negative about anything. We don't know. We just really don't know. Maybe that'll help. Maybe students will get together at a lab next, right here in Iowa State and put together something, and that can really help. I really feel that we are in this new phase of solutions. We have to. What are the ideas? We have to test them, see what works, and we're in a state of ferment about this. So, I think the previous questioner too said, don't close off anything yet. So I guess I think students, go for it. It would be very exciting to have Iowa State students win it. Jim is on the committee, by the way. My boss is on the committee choosing the winner. And I hope they do a few winners, not just one. Hi, Ben.
Okay.